So we're going to do one last problem here for section 3 or 8.3. That is to find the centroid of region bound by these curves. Now, if you wanted to, you could turn on this to shade the area between these two things. We want to find where you'd put your finger underneath that plate to kind of balance things off. So if I shut everything off, there you go. Where's the balancing point? Well, there's some work we got to do. So let's switch over to my artist rendering. And any difference between my sketch and the sketch that we just saw must be purely video distortion, because this is an immaculate sketch. And work with one slice like we always do. Find that helpful. There, there, there. So it's a DX slice. The first thing we need to do is we need to calculate the mass of this region, or the area. So we'll call it M. That's going to be the integral from -1 to 1. Well, that comes from the endpoints of our little region here. So if I put these graphs back, there you go. Nice features on Desmos is that you can click and I will find those. So -1 to 1 is going to be the limits of our integration. This first part is just going to be finding an area. So area is going to be the top function minus the bottom function times the thickness. So top function is going to be 3x cubed minus 3x minus the bottom function, which is 3x squared minus 3. Notice I was careful to put both of these in parentheses. You need parentheses around that second one because that negative has to distribute itself to both terms here. So that's the height, top minus bottom, times the thickness, which is just dx. And there we go. Now you can clean that up a little bit. Top minus bottom. And that's your thickness. You can clean that up a little bit. It doesn't clean up to anything beautiful. -1 to 1 of 3x cubed minus 3x squared minus 3x plus 3, if you're to write things in descending order. And per usual, jump to the happy ending. Interestingly enough, this crazy little figure here has an area which is an integer, which is actually exactly 4. So, all right, that's the easy part, I hope, finding the area. The harder part is going to be find m sub x and m sub y. So let's work with m sub y first. M sub y is going to be the tendency to turn around the y-axis. So let me squeeze in a little y-axis here for us just for reference. This is not going to be drawn to scale by any means. But I want to try and find the distance between here and my y-axis. That's going to be part of my integral. The integral is going to go from -1 to 1, just like the area integral did. That distance, what is that distance going to be? Does anyone remember from the first couple problems like this?
X.
X, thank you. X times the area of that one slice. So times the area of the slice. Oops. So that's going to be our top function minus the bottom function. 3x cubed minus 3x minus 3x squared minus 3 times dx. So height times width. Now, this we already know simplifies like this. If I distribute the x, I'll end up with the integral of 3x to the 4th minus 3x cubed minus 3x squared plus 3x dx. By now you regard, or you might recognize the fact that I have very little interest in doing out all this stuff by hand. So let's just put in a negative 4/5.
I apologize. Can you dummy it down for me and show me how you got 4 real quick?
Here?
Yes.
Well, there's two ways. One is with the calculator with FN int, and the other one's by hand. Which one did you want?
Neither, thank you.
Okay. You're sure?
Yes, thank you.
Okay. And the same thing here. I sincerely doubt that I actually did this one by hand. It's not that I can't. It's just that, look, this is just Calc 1 stuff. And even then it was kind of on the easier side for Calc 1 stuff. So I'm assuming we can find these values. But if you have some problems, please get some help. That'd be worse than anything, is if you had a question and you weren't getting it answered. So let's work on finding the rotational force around the x-axis. This is where we need the average height, or the midpoint of this. Now, if we look all the way back to the first part of the video, or the first video in this 2-video sequence, one thing I had here was, for the moment around the x-axis, we had f of x plus g of x divided by 2, and f of x minus g of x. This was the area of one slice. This is the average midpoint. But there's actually some simplification you can do here. And let me see if I can't share that with you. I'm going to put that on a different sheet of paper here real quick. So we look at our integral from a to b of f of x plus g of x over 2. You don't have to copy this down. Just copy down the happy ending. F of x minus g of x dx. The 2 can factor out. So it's 1/2 the integral f of x minus g of x, actually plus g of x, and f of x minus g of x. Does anyone recognize what happens to something in this form? If you had a plus b and a minus b, for instance. What happens when you multiply that kind of stuff together?
Perfect square, or
a squared minus b squared.
Yeah. So it's the difference of squares, right? You're gonna, if you FOIL this out, this is your algebra skills here. So it's a squared minus b squared. So rather than writing all this out, I'm just going to regard this as f of x squared minus g of x squared dx. And that can be a welcome shortcut in this. So for us, our f of x is going to be the top function, and g of x is going to be the bottom function. It's just going to be a little bit friendlier way to write this. So we'll do the 1/2, take that out in front, times the integral from -1 to 1 of the top function, which is my 3x cubed minus 3x squared, minus the bottom function, which is 3x squared minus 3, again squared. All of that times dx. And there you go. Let's just, for sake of completeness and for grins, let's put that into our graphing calculator and show you what that's like. So I'll do it on this. You know what? Sorry, it wasn't open. And for whatever reason, TI SmartView seems to want to take a while on my computer. It's a nice program, it just takes a while. Okay, oh, some stuff from the other day. Let's clear that out. And start by hitting Math 9. Do an integral from -1. Make sure you use the negative key on the bottom of your calculator, not the subtraction key. You'll get an error. -1 to 1. And the first thing I need to type in is a parenthesis. So left parenthesis, and then 3x cubed, 3x raised to the third power. You got to hit the right arrow to exit the exponent, minus 3x. And then I want to hit the squared key, minus parentheses, 3x squared. So again, I'm going to hit the squared key, which is nice because now you don't have to hit the right arrow to exit the exponent, minus 3, another right parenthesis, and then another squared, because we're squaring that, and then dx. And press that and hold our breath. And let's see if that turned out to anything special. I'll hit the math key. So -288 over 35. So let's write that one down. So how was that? You guys able to duplicate that, get that on your graphing calculators at home? Okay.
Yeah.
Thank you.
We still multiply it by a half though, right?
You're right. All right, so that's perfect. Times 1/2 is going to be -144 over 35. So just cancel the 2 there. Thank you. Okay, almost done. Let's calculate the actual center now. All we're going to do is take a couple of these values and divide it by 4. So x bar and y bar, m sub y divided by m sub x divided by m. So m sub y divided by m, oops, how about this one? M sub y divided by m, -4/5 divided by 4, and -144 over 35, again divided by 4. If you're not comfortable with this, you're like, oh, I'm not so good with that. You know what? Do it on your calculator. You should get -1/5 and -36 over 35 like that. But like I said, if you're not comfortable with that calculation, if you can't simplify these things very easily without too much strain on the brain, here you go. Let me just clear this out. An easy way to do that would be with parentheses, and I don't even think you need to type in the negative if you don't want to. -135, -144 divided by 35, right parenthesis, divided by 4, And they're like, oh, God, I don't know, what's that? Well, hit the math key. Press enter twice. So negative 36 over 35. Does that make sense? Let's compare that to our figure. And I've actually got that point programmed in. So if you plot it, yeah, that looks reasonable. Now, if you saw something in the tail or even worse, outside of the figure, then yeah, that would look really, really bad. I mean, it's not like you're going to be able to tell if this is fractionally off, but you can tell at some point it's going to, you know, it's going to look wrong. At which point I hope that you say, all right, I have to go back and check myself. That was a long problem.
Can you go back to the work? Thank you.
Is there anything in particular about the work here that I can help out with?
I'm kind of confused on that thing you did where you did the
All the
different
squares?
figures. Yeah, that.
Yeah. So what we're calculating, or what you have to calculate to find your m sub x is, is this part right here. And what this is, it's the average of these two functions, which gives you the height of the midpoint. So height of the midpoint. So if we go back here, it's going to be your top function plus your bottom function divided by 2. And that's going to be the height of that midpoint. So that's where this one comes from. The other part of this is going to be the area of that one slice, because this slice tends to turn things around the x-axis with a force that's felt at the midpoint times the area of that slice. So that's what the next part of this is. It's the area of one slice. Area of one slice, which is the height, your top minus bottom, times the width. The width is just your dx, and there's your top minus bottom. So this is going to happen for all of your different m sub x type problems. So if you just wanted to jump right to here and calculating m sub x, you could. And a fair question might be, well, why didn't you show us this ahead of time? Well, I didn't, because in our first couple examples, g of x was 0. So it wasn't as useful as it was in this problem. But if you have a top and bottom function that are both different than 0, then this idea can be pretty useful. Is that helping out? Is there something more I can add there? Something, a detail that you're still not getting? All right. Any other questions on this one? Okay, cool.